Hello, today we are learning significant figures. Significant means like which figures are important while writing any measurement or while writing any amount. Okay, so here there are some rules which I have written one by one. I will be explaining you. So, first rule is that all non-zero digits are significant always. Like I have written here 1325, like 1325. It means it has four significant figures: 1, 2, 3, 4. It has four significant figures. Okay, like we cannot just write 1300. Okay, because 1325 means 1325. Okay, these are all constant numbers. Then the second rule is all captive zeros, like all which are sandwiched between two non-zero digits, they are significant. As we can see here in example 1002, so here these two zeros, they are captive zeros. They are between two non-zero digits 1 and 2. So here they will be counted 1002, because if I write it in standard form, then how I will write? I will write it as 1.002 times 10 raised to 3. So these are all important here. Same thing here also you can say. If I write it in a standard form, this will be 1.325 into 10 raised to 3. So that is why they are all important, right? We cannot ignore any digit. So understood? Now, next is this. All zeros to the right of a non-zero digit but to the left of a decimal point are significant. Okay, so here what is this? See, I have written one example. This is 10,500 point. Okay, it means that which digits, which zeros we are talking about? All zeros to the right of a non-zero digit but to the left of a decimal point. It means these zeros we are talking about. Okay, so here they are important because they are to the left of a decimal point but they are to the right of a non-zero digit. So these will be counted, because when I will write this in standard form, I will write it like this: 1.0500 into 10 raised to the power 1, 2, 3, 4. Okay, it means that my instrument is measuring up to 4 decimal points. It is that much accurate. Okay, so next is always remember, whenever decimal point is there after the figure and before to the left of the decimal, if there are zeros and those zeros are to the right of non-zero digit, it would be counted. Okay, do not ignore that. Then the number is, if the number is without decimal point, and in that case those trailing zeros will not be counted. Like here you can see 30,700, but here there is no decimal point after two zeros after 7. So these two zeros are not important, because when I write this in a standard form, I will be writing what? I will be writing 3.07 times 10 raised to the power 1, 2, 3, 4. So these will be my significant figures. Okay, in this case, these were my significant figures. Got it? Okay. Next rule is all zeros are significant if they are written as measurement. Like here I have taken like 20,020 meters. So here everything would be significant, like 1, 2, 3, 4, 5. So we say that this 20,020 meters has 5 significant figure. Here we won't ignore this trailing zero. Okay, and next is, so this is case when some unit is mentioned here. Okay, now next is if the number is less than 1, like 0 point something, if the number is less than 1, the zeros on the right of the decimal point, but right to the decimal point, but to the left of first non-zero digit. Left of first non-zero digit, they are not significant. Why? Because if you are asked to write this number in standard form, we will be writing it as 7.45 times 10 raised to what? 1 2 3 4, so minus 4. So 7.45 times 10 raised to minus 4. So here only 3 figures are significant. Got it? Okay. Next is what? All zeros to the right of a decimal point and to the right of non-zero digit, they are significant. Like here you can see we have written 10.00. So 10.00, like if I write simply 10 centimeter, okay, so it means that my ruler is counting correct up to 1 centimeter only. But if I am writing 10.00 centimeter, it means that my ruler can measure say 10.13 centimeter. My ruler can measure up to 2 decimal points, correct up to 2 decimal points. Hence, these zeros would be important and it would be 10.00. Okay, and if I write it in a standard form, I will be writing it as 1.000 into 10 raised to the power okay, or we will not write it in standard form right now. Wait, yeah, so like the meaning is like accuracy. Here we can talk about not a standard form, here we can talk about the accuracy of our measurement. Okay, so this is giving you correct up to 2 decimal place, that is talking that term accuracy. And here it is say 0.070400. Now here also every zero is important and it is significant. So this is like, this one is not significant, this one is not significant, but these are all significant figures, right? Because this is to the right of decimal point and left of non-zero, so that is not important. But 70400, they are all important here. So that is why it is having 5 significant figures. Then coming to the 8th rule, where we have the number of significant figures does not depend on the system of units used. So whether I write 1.53 centimeter or I write the same measurement into meters, so it will become 0.0153 meters because we will divide by 100. Then if I write it in kilometers, it would become divided by 1000, so it would become 0.0000153 kilometer. So they all are having 3 significant figures. Okay, then power of 10 is always irrelevant to the determination of significant figures. So I can write like 2.70 meter as 2.70 times 10 raised to 2 centimeter, or 2.70 into 10 raised to 3 millimeters, or 2.70 into 10 raised to minus 3 kilometers. So they all have what? They all have just 3 significant figures. This 10 raised to 2, 10 raised to 3 or 10 raised to minus 3, they are irrelevant. Just ignore those powers while mentioning significant figures. Right? Now let us do few questions which I have already written here. So the first one is like I have written the number and I have written like up to which number of significant figure we have to write these numbers. So how we do it? Like here I have written 2130.62. Now we have to write number of significant figure should be 1 only. So how I will write? Number of significant figure should be 1. It means that I have to round up this number 2130.62 up to 1000. Up to 1000 I have to round it up. Okay. And when I round it up to 1000, then my number will become what? 2000. My number will become 2000 here, right? Because after 2 we have just 130, which is less than 500. So my number will become 2000. Now this is correct up to one significant figure, 2000, right? Now let us see the next example. This is 269.43. They are asking me to write number of significant figures should be 3. Number of significant figures should be 3. What does it mean? That we have to round it to the nearest, you can say round it to the nearest one, because this is just 3-digit number, right? So I will round it up to nearest one. So after decimal I have 4 here, so it will be 269 only. Got it? Then next is 48,647.5. We have to write one significant figure, this whole number. So it means that what I have to do here, number of significant figure is just 1 here. So this is 1, 2, 3, 4, 5. So it means that 10,000, right? I have to round it up to 10,000. So it would be like, this is 48,647.5. So I will be writing it as what? 50,000, because after 4 we have 8, which is greater than 5. So it would be 50,000, right? Next is 29.1933. Okay, and we have to write correct up to 2 significant figures. Okay, 2 significant figures means like we have to round it up to 1 only. Yes, round up to 1. So it would be 29 only, because after decimal there is 1, right? It should be 29. Then we have next 78.3795. We have to write correct up to 3 significant figures. So I can write it as what? See, after 7, after 3 I have 7 here, right? So I will round up this number. This number would be increased by 1. And let me write here. So we will round it up to, you can say 0.1. Yeah, we can round it up to 0.1, right? And so this number 3 would be increased by 1, and I will write it as 78.4. So this is how in 3 significant figure we have written this. Now the next is 6576.68. Correct up to 3 significant figures, like we have to write this much only. So it means that we will write correct up to, this is 10th digit, so round up to 10, right? So it would be what? This after 7 we have 6. It means this will become 658. Correct? This will become 658, and then in place of 6 we will write 0. Got it? Then we have 43.2221, and correct up to 3 significant figures. So this is again up to 0.1 I will write, right? I will round it up to 0.1 again here. So correct up to 0.1. So after this 2 there is just 2 here, so I will write 43.2. Then the next is 66.8765. We have to write correct up to 4 significant figure. Now we can do little fast. So it means that these all, but after 7 we have 6 here, so correct up to 0.01, because 2 decimal figures. So I will write it as 66.88, because after 7 it is 6, so 7 would be increased by 1. Now we have 2 millions, 247,406, and correct up to 4 significant figures we have to write. It means like this. So we have to round it up to this thing 100, because this is hundreds place. So we have to round it up to 100, and that would be what? After 4 we have 06, right? So that would be insignificant. So I will write 2474000. That's it. Okay, so here we have 4 significant figures. Then correct up to number of significant figure is 3 here. So we want only this much. It means that this is, we have to round it up to 1000 because this is thousands place. So we have rounded up to 1000, and that I can do. After 2 I have 5. It means that my this number would be increased by 1, and hence I will write 803000. Clear? So this is how you can write the number of significant figures. Yes, I hope you have understood. So keep practicing. We will be practicing few questions also in class. So all the best.